So today in this video we'll be taking a look on qwen-image model. So currently we'll be taking a look on two models, that will be qwen-image and qwen-image edit 2509. So it also supports multiple images and improve consistency. So this is the official release done by Alibaba team, and here are all the details. So I'll be adding this on the description section as well, so this both will be added there. And today what we'll be doing is here are sets of prompt that we'll be using. So the prompt are of different categories. So currently I'm taking 10 categories. So first one will be precise object manipulation and localization. Second one we have multiple object selective editing. Third one we have object addition, spatial reasoning. Fourth one we have object removal in painting quality. Then we have object replacement, consistency testing. Then we have texture and material transformation. Along with we have background replacement, context preservation. We have lightning modification, which falls under technical precision, and we have time of day transformation, also weather and atmospheric condition. So if you see, it sets of prompt consists of two prompts. So the first one is for generation. So for this prompt we'll be taking qwen-image model, text to image model. So this will be generating a image for us, and then we'll be using that image on qwen-image edit 2509, and this will be the prompt for changing or editing the generation that it gets generated from here. So first up we'll be taking 10 of these prompts for the generation, and we'll do the edit itself. So this generation might take a bit of time, but I'll be showing you 10 of these, and others I won't be recording the video live, so I'll be adding this over video, and also I'll be adding the images here itself and sharing this file to you, so that anyone following this will be having proper insights around how this model works. So for this I'll be using Docker desktop. So let me first run Docker desktop here. Okay, let's wait until this gets started. So this is the Docker image that Docker desktop that I'll be using. So here you can see I have a sets of images. So this is the image that I'll be using. So this is NWK ComfyUI boot CU129 slim, and it's 20.84 GB. So it consists both the models for qwen-image and qwen-image edit 2509. So here you can see there is a container. So I just started Docker desktop and it automatically ran the Docker compose for us, and through this what we can confirm is that our ComfyUI server is loading. And if you want to see the logs for here, we could see the logs. So these are the earlier logs that were stored here. So this is the ComfyUI and here we can see. So let me clear all this first, and let me go to browse template, and I'll be selecting two templates. So qwen text to image will be one of the template that we'll be using for image generation, and we will be using qwen-image edit for doing the changes and manipulations on the earlier generated image through qwen-image. And anyone within this Gen AI or within content creation through AI, as you might all know, the recent release of Nano Banana through Google team. So it's remarkable, and through qwen-image edit as well, we can achieve similar results. And what's good thing about Qwen is it's completely open source, unlike Nano Banana, which is closed sourced. So yeah, basically what I'm generating is completely free, and if you were to run similar prompts on Nano Banana or any of the other paid alternatives, so that will be charging us a lot. So that might be minimal for limited generation, but for multiple generations and for integrating it into an organization, that could save us a lot using this kind of open source model, and the results are also remarkable. So without ado, let's get started. So I am here at this one, so I'll be copying the first prompt. So also this prompt is generated through AI. So let me set the height and width to 1024, also 1024. So we'll be having a square image generated, and for the sake of this video I like to reduce the steps to key sampler steps to 10, which will reduce the time. So the first generation might take a bit of time, so let's see how long it takes to generate this. And if you see VRAM usage for RTX 4090D 24 GB, so this is the configuration it suggests: FP8 EFO M3FN with 8 steps LoRA. So the VRAM usage you will see is around 86%, and first generation it takes around 94 seconds. With 8-step LoRa, the first generation time is reduced to 55 seconds, and with distilled FP8 we get the first generation in and around 69 seconds. So second generation you could see the time is slightly reduced because first generation needs to load the model. So if you see model loaded completely true, and so it's loading the model. So model load takes some time for the first generation, and eventually the second generation, and the latter one gets less generation time as you see here. So yeah, this is the current one, and if you see we have FP8 one diffusion model for qwen-image, and we have a LoRa, so it's qwen-image lightning 8-step LoRa, and we have text encoder and VAE qwen-image VAE safe So talking about these files, so these are quite heavy file, somewhere around 19 to 20 GB for this diffusion model. LoRa is also around, I think, 7 to 8 GB. So yeah, that's how it works. So yeah, we can see the logs in the real time. So model loaded completely and requested prompt executed in 84 seconds. Now we could be able to see that our generation is successfully completed. So the generation might be a bit. So let's do the steps to 20. So first generation it took 84 seconds for 10 steps. Let's see how much it takes. And a single red ceramic cup mug on a white marble countertop, soft window lighting from the left, Foge product photography. So this is the generated image that we get. Similarly, I'll be doing for first 10 sets of prompt here. We have another one. Let's run this as well. Similarly, let's run the other one. So I think I prompted 8 prompts. Let me also do the next 2 prompts as well. And the last one for the test will be a self with 7 works one. Okay, so let's see the generation. So this is the second one, this is the first one. So yeah, these are the kind of result that we get, and along with this, let's see how the storage is working here. So inside files, if you see, okay, let's go through volumes itself. So current volume I think it's using is, okay, not this one. Let's see here, or let me show you through here itself. So I came here, and this is the storage that it's sharing. Okay, so let me go to Comfy, not here, models. Let me go to diffusion model. Here we can see, so the current one is this one. So let's see the properties of this, and you can see it's 19.0 GB. So the model is only 19, diffusion model is only 19 GB, and along with that we need LoRa, VIE and similar, so that's also heavyweight. And along with this we have this image edit 2509, and it's also 19.0 GB. So that's how the model are loaded locally and it's working accordingly. So currently we could see we have 32 CPUs available, and it could extend up to 30 to 100 percentage, and it's somewhere around 110 percentage. So since it's GPU intensive, so the CPU utilization is quite low compared to the GPU. And let's get here, and so if you want to expose it to Cloudflare, this we could use this command. What it does is, since my container is listening on port 8188, so it's redirecting it to this URL, and if I go here I could get the same UI. So this is for local host, and this one will be to expose the same interface through internet using Cloudflare. And yeah, that's how it works. So also let me run git bash once and let's see the GPU utilized. Okay, it's RTX 5090 and currently, so the generation stops, so the usage is also dropped. So I'm using the driver 576.88 and the CUDA version that I'm using is 12.9. Other, as it is. So yeah, that's how it's been running. And let me come back here, and what shall we do is we'll go to browse template. We'll select the other template, that will be image edit one, and sequentially I'll be copying the image generated here and I'll be using the edit prompt from here. Let's go through first image and change the mark to cobalt blue. Let's see how it works. And the best thing is, similar to this, we could, provide 3 reference image and it works exceptionally well through all 3 multiple images as well. So for today, we'll be using a single image and we'll be doing the edit here and see the result. So for the first one, change the mark to, and on the later video that I'll be posting, I'll be adding multiple references and we'll be checking this. And not only this model, we'll also be taking a look on other video generation and audio generations model as well. So I'm running this. So first generation, as I mentioned, so the model load for the first time will be taking some time, and after that other generations will be small, will be taking lower time. Yeah. So I updated the first image. Let me also add the second image. Let me copy the prompt here. Okay, so this was the first generation. So we asked it to, the edit what, change the mark to cobalt blue. Let me cancel this. So this is in red color, and if we could see, it must be generated in cobalt blue. In the meantime, I'll also be pasting the other ones as well. Change the base to emerald grass while maintaining the refraction pattern. Okay, running this, we have a watch here. Change the watch case to rose gold while keeping the letter stripe black. Okay, I'm running this. So the copy changed to cobalt blue. No other changes has been made. The references over the behind is kept as it is, and just the color is changed. And same goes for this one. So the red apple converted to, what was the prompt? Change the base, no, sorry, this one. Change the apple to bright yellow while preserving all water droplet and reflection. So the water droplets and reflection is as it is. It just changed, the color from red to this. The other one we did was base one. So change the base to emerald green grass while maintaining all light reflection pattern. Change the watch. Okay, I updated, and the watch, I don't think it did much of change to this one. So let me specify over the prompt itself was keeping case to rose gold. Okay, I'm changing the watch case to blue, and as you can see the steps is 4, which is quite low. Let me increase this to 10. That's why the generation time also got. Okay, what it did was it did not change the dial color, but the frame color. Straps are remaining the same. If we see here what was the color, so it looks like silver, so it converted to rose gold, and I asked it to convert it to blue, so accordingly it's converted. So this is what we did using 10 steps, and this was the generation using 4 steps. So you will see the quality of generation. I think this one looks great compared to this one. And the time also, you could see the 4th step generation took 9.45 seconds, while 10 steps generation took 15.57 seconds. Along with this, now we come to the sofa image. We have this one. Change the, okay, this is the one. Change the chair upholstery. Run. We'll also, okay, I'm adding this here. So let me select the prompt. The prompt would be this one. Run. Then the other one we have is change the red balloon to purple. Run. Then we have a base with rows. Change the 3 rows to pink and 2 white rows remains unchanged. Okay, let's see the difference in these two images. So this was the one that we applied, and the one that we pasted was the chair upstairs to forest green velvet while maintaining the same texture and pattern. So this was the earlier one, and you could see the color change, keeping background lighting and everything as it is. So this is the one, apple and a pear. Apple and a pear, you could see the color changed of apple from red to this one. Similarly for balloon we have this one, and red, blue, yellow, which converted to blue, red and yellow. The vase similar to this, the 3 converted to pink and 2 white remained unchanged, which was the case. So we already had 3 red roses and 2 white, which converted to pink and 2 left unchanged. Yeah, basically this is how it works. And okay, let me do the 2 as well. Yeah, this one goes here. The changes will be change the navy blue stripes to turquoise, keep the white stripe. Okay, so the navy blue stripes will be changed to turquoise. So this is the blue and white stripes. Let's see how it converts it into turquoise. Similar to this, change all the red books to green, keep all the black books unchanged. So we are converting red books to green and black books unchanged. Yeah, if you see navy blue converted to turquoise color. Okay, so what I'll do is I'll be adding all this into these sets. Not here. Okay, this will be here. Generations comes here. Okay, this comes here. So this is how I'll be adding all these onto this request access. Why it's getting okay? Similar to this, I'll be adding all this so that you will have this document and the images as well. And anyone who is willing to take this generation into some resource purpose work or anything for their model comparison, you are okay to take these images. So yeah, that will be it for today. So this is how we can run nano banana equivalent to open sourced model to do the things. And what this adds as advantage is you could take any of your images, any e-commerce company, any product based company want their product and want to do edit. So this provides us with Adobe Illustrator or Adobe Photoshop equivalent of editing capabilities. So this is a great tool. I recommend anyone who is trying to delve into Gen AI and other foundations, please take a look into the tool ComfyUI itself and the models that it provides. So yeah, open source do have a lot of alternatives that we could use as per our need and demand. So I hope this has been an insightful video for anyone who is trying to take a look into how Gen AI works and how image generations is shaping the new AI landscape worldwide.